Moving on to page 3, number 16. Find the area of a circle with a circumference of 30 pi. Well, it wants to find the area, and the area is pi r squared. Now, I need to know the radius before I can move forward to finding the area, and it gives me the circumference. Now, I know that my circumference formula is 2 pi r. So I'm going to plug this in and then solve for r, then take r and plug it back in over here. So we've got 30 pi is equal to 2 pi r. To get r by itself, I divide both sides by 2 pi. Those guys divide out, leaving me r alone on the right. Now these 2 pi's also will divide out, and 30 divided by 2 is 15. So I take this and plug it back in over there. Area equals pi times 15 squared. Let's plug that in. Pi times 15 squared is 706.85, so 706.9. And then that is units squared, so I'm not going to worry about my units there. I guess I should probably put units squared there. But, all right. Find the area of the shaded sector. It's kind of hard to see in this copy, but this is my shaded sector. And it tells me that that angle for angle ABC is 60 degrees. So, area is theta over 360 times pi r squared. Gives me a radius of 25. So area is 60 over 360 times pi times 25 squared. 60 divided by 360 times pi times 25 squared. Oh, you can't even see that. There, so we type it, and we've got 327.2 inches squared. All right, number 18. Find the area of the figure. Again, this one's composite, and we're finding the area of this whole thing. And so looks like we're going to find the area of the rectangle and then subtract out the area of the circle. Let's do the rectangle first. Area formula for a rectangle is just base times height. So the base is 14, height is 4, so it's just 14 times 4. And I can't do that one in my head. 14 times 4 is 56. Now let's find the area of this semicircle. Now, first off, we're going to find the radius. Well, I'm taking it back. Let's do the formula first. Area of a full circle is pi r squared. However, in this case, we're only dealing with or cutting out half the circle. So I'm going to go ahead and cut that in half to get the area of the semicircle. So I need the radius. Well, if the full distance across is 4, that means my radius is going to be 2. So area is 1/2 times pi times 2 squared. Well, 0.5 times pi times 2 squared is 6.28. So let's just call that 6.3. So the area of the whole composite figure is, subtract them, the rectangle minus the semicircle. And that one's going to come out to, my stuff got, that's 18 up there. Okay. That's going to come out to 49.7 feet squared. All right. Number 19, a circular pool surrounded by a circular sidewalk. Sidewalk is 4 feet wide and the radius of the pool is 25. Find the area of the sidewalk, which is this shaded region. Okay, so we're just going to find the area of the larger circle minus the area of the smaller circle. So let's do the larger circle first. Area is pi r squared. Now the radius all the way to the outside, this one is 25 and that's 24, so the whole thing is 29. So area equals pi times 29 squared. pi times 29 squared, 2642.1 feet squared. All right, area of the smaller one. Same formula, pi r squared. So it's pi times 25 squared. So same thing, pi times 25 squared is 1963.5. And then we're just going to subtract those. 2642.1 minus 1963.5 gives me an area of 678.6 feet squared. All right, number 20. Wanting to find the area of the shaded region. Here it looks like I've got a square because they're both 18. And to subtract out the circle, let's go ahead and, we know we need the radius. If the distance all the way across is 18, then my radius is going to be 9. So let's do area of the square is base times height. So it's 18 times 18. 18 times 18 is 324. Area of the circle is pi r squared. So that's pi times 9 squared. Pi times 9 squared is 254.6. And then let's go ahead and subtract those. 324 minus 254. Oh, that should have been a 0.5, not a 0.6. Sorry about that mistake. That gives me 69.5 units squared as my area of the shaded region. Okay, that's everything for our two-dimensional area for this review. Everything here on out is going to be surface area and volume. So to switch gears a little bit. Just like before, I'm going to be writing my formulas in for everything before I actually go through and start plugging things in. All right, number one, pretty simple. Identify this solid figure. Well, I see I've got a single base with a vertex at the top. Tells me it's going to be a pyramid. The real question is, what kind of pyramid? Remember, pyramids are always named after the base. I've got 4 sides, and all 4 sides are equal. So I'm going to call that one a square pyramid. If that had been an octagon, it would be an octagonal pyramid. If it was a triangle, it would be a triangular pyramid. Okay, name the base. Now, the base is a square, and so technically, I mean, people want to write square there, but that's not it. The name of the square is the name of the points. So it's square A, B, C, D. Remember, when we're naming a polygon, we start at one vertex and then work our way around. All right, find the surface area of the cube. Well, surface area for a prism, surface area is 2 times the base plus the perimeter times the height. Now, let's make sure we're saying these right. I even made a mistake there. Capital B is not just base, it's area of the base, and capital P is perimeter of the base. I'm going to use this bottom side as my base. Since it's a cube, I could pick any side, it doesn't matter. That's fine. Capital B first. Area for a square is going to be little b times little h, so that's base times height. Base is 3, height is 3, so it's 3 times 3, which is 9. Now I need capital P. Capital P is perimeter of the base, which is just for a cube, number of sides times side, so that's 4 times 3 is 12. Now height is the distance between the two bases. In this case, is just going to be 3. So I'll plug all those in. Surface area is 2 times area of the base is 9, plus perimeter is 12, times the height is 3. 2 times 9 plus 12 times 3 gives me 54 inches squared.